Please like, subscribe and share and click the bell icon to get notifications from YJ Education.
Hi friends, welcome to YJ Educations. In today's video, I am going to explain you about the properties of even and odd functions. Before that, let us see the definition to find or the conditions required to find whether the given function is even or odd. In discrete time domain, to find the given function x of n is even, the condition is x of n is equal to x of minus n. In continuous time domain, it is x of t is equal to x of minus t. To find whether the given function is odd, in discrete time domain, the formula is or the condition is x of n is equal to minus x of minus n. In continuous time domain, it is x of t must satisfy the condition x of t is equal to minus x of minus t. The first property of even and odd functions is symmetric nature. Remember that even function is always symmetrical about the y-axis or vertical axis, but considering odd function, it is always symmetrical about the opposite quadrants. That is, in even function always there is adjacent symmetry. Here in odd functions there is opposite symmetry. That is, if you take the signal as in Q1, the opposite signal will be in Q3. If the signal is in Q2, its symmetrical signal will be in Q4. The second property is when you integrate a even function. If suppose here f of t is even, when you integrate this even function, its area, it means you are finding the area from minus infinity to infinity. If suppose if you take the signal in this manner, this is an even signal, this is continuing from minus infinity to infinity. If you integrate this from minus infinity to infinity, its area is same as twice the area from 0 to infinity. Twice the area from 0 to infinity. The formula is same in discrete time domain. Minus infinity to infinity if x of n is even. Here the formula is same, but initial value will be added. X of n 2 times plus its initial value will be added. Now what happens if you integrate odd function from minus infinity to infinity? If suppose f of t is an odd function, then this value will be 0. It means the whole area covering the odd function is 0. It is in continuous time domain. In discrete time domain, it is sigma n is equal to minus infinity to infinity x of n equal to 0 in discrete time domain. Third property is the differentiation property. It means what happens when you differentiate an even function or an odd function. When you differentiate an even function, the condition required for an even function is x of t is equal to x of minus t. If we differentiate with respect to t on both sides, we get x dash of t is equal to x dash of minus t into the differentiation of minus t is minus 1. It means x dash of t is equal to minus x dash of minus t. If you take it as f of t, this is equal to minus f of minus t. It means it is an odd function. Therefore, when you differentiate an even function, you get an odd function. Example is when you differentiate the even function cos, you get an odd function minus sin t. What happens if you differentiate an odd function? If you differentiate an odd function, let us take the condition for odd function, which is x of t is equal to minus x of minus t. Differentiating on both sides gives x dash of t is equal to minus x dash of minus t into differentiation of minus t is minus 1. X dash of t is equal to x dash of minus t. This is like f of t is equal to f of minus t, which means this is an even function. Therefore, when you differentiate an odd function, you get an even function. Example you can take as, if you differentiate sin t, you get cos t. Here sin t is an odd function, cos t is an even function. What happens when you multiply two even functions or two odd functions? Here you can remember or you can imagine even function with respect to plus and odd function as minus. Now when you multiply two even functions, it means you are multiplying two plus signals. Then plus into plus is plus. It means you can remember it as even. Now, when you multiply even and odd function, it means you are multiplying one plus and one minus, which results into minus, which is odd. When you multiply two odd signals, it means you are multiplying two minus, which results into plus. Plus means even. So these are the three rules where multiplying two even signals give even, multiplying two odd signals give even, and multiplying one even and odd function gives odd. Here the fifth property is that if x of t is any signal with even part as x e of t and odd part as x o of t, then when you integrate from minus infinity to infinity x of t and x of t whole square, and if you want to represent it as the sum of the integration of even and odd parts, then you can write it as integration minus infinity to infinity even part square plus odd part square. Proof. Let us see the proof for this. Integrating minus infinity to infinity x of t whole square dt is equal to x of t can be written as sum of even parts and odd parts. Now if you substitute this equation here, you get minus infinity to infinity integral x of t can be written as x e of t plus x o of t whole square. It is like a plus b whole square, which can be written as a square plus b square plus 2ab. Next, here if you expand the integral, you will get integral minus infinity to infinity x e of t whole square dt plus integral minus infinity to infinity x o of t whole square dt plus 2 times integral minus infinity to infinity even function into odd function. Remember that in the previous property we have seen that multiplying one even function and odd function gives, it means you are multiplying one plus and minus, which is odd, minus. Therefore, you are integrating, multiplying two functions, which is one is even, one is odd, gives odd function, and you are integrating this odd function from minus infinity to infinity, whose value is 0, and the remaining part is minus infinity to infinity x e of t whole square dt plus x o of t whole square dt. The same property in discrete time signal, sigma n is equal to minus infinity to infinity if x of n is any sequence, then adding its squares gives, and if x of n can be written as sum of its even sequence and odd sequence, then we get in this manner, plus minus infinity to infinity x o of n whole square. Thanks for watching this video. Please like, subscribe and share.